But again, I would like to thank and recognize Frank for all of his support.
Aye.
And all of you have done a great job as far as getting this up. Hopefully, and as Brian will discuss, what our odds of getting this constructed this season. I think we're still talking, what, 50-50? And he'll go into why the odds are right there and what we're looking at. Thank you.
All right, well, once again, my name is Brian Nicholas. Thank you, John. I presented to you back in October, and at that time we promised to provide an update to the council and the citizens of Sheridan about the project status, and we were shooting for January. Had a few, well, I would say hiccups, a few technical challenges we had to get over. However, so we're a little late in providing this update, later than expected to provide this update to the council. But in terms of design progress, we're exactly where we had planned to be back in October at this time. So there are a couple of items that we talked about back in October. I'll provide you an update about those items. We'll talk about schedule and the scope of the project, and answer any questions that the council or citizens might have. All right. So if you'll remember, we had a couple of items that we wanted to open up to public comment, and one of those items had to do with the fixtures, light fixtures that are on the bridge. And we had posed 3 alternatives. The first alternative being keeping the fixtures that are on the bridge. Second alternative was to replace these fixtures with a modern replica of the original designer's intent, which happens to be an almost exact copy of what the city already installed on Main Street. And so the question was, hey, should we replace the fixtures that are on the bridge with what's already on Main Street? And the final one was to reinstall new fixtures, a replica fixture that was made to replicate the appearance of the fixtures that were originally installed on the bridge, which didn't match the original plans. And the overwhelming response was to replace the fixtures with a replica that matches the original design intent, that also happens to be the most economical alternative. So we posed that to the State Historic Preservation Office. They've granted us approval to move ahead with that. So alternative B is what we're proposing to move ahead with. So the 5 fixtures that are on the bridge, the plan is to move ahead and incorporate exactly what you have on Main Street, which will provide a good tie with what you see up and down Main Street. So I wanted to provide an update on that item.
Will they have the black posts, or are you going to keep concrete ones?
We're going to keep the concrete posts. That's a defining feature of this bridge. And as part of the scope, the concrete on the rails will get patched. We'll remove any chipped or loose concrete. We'll patch that up. Everything will get what's called a sack finish, so water blast the concrete. And sack finish is you take some cement paste and you rub it on the surface to give it a nice clean appearance. It'll look, when the bridge is done, these rails will look almost new. They'll look very similar to their original appearance. And the concrete rail and the steel inserts will also be painted. So you'll have a nice consistent appearance when that's all done. So, yep. And obviously that ties into the light fixture and light poles. So. The second item that we opened up to public comment was the rail, and I want to spend a minute talking about this in case there's any questions. So we had proposed three possible alternatives. The first one being a very utilitarian, low-cost installation, easy to maintain. That did not receive much support, and we didn't really expect that it would. The second one uses what's called an ODOT standard 2-tube rail. Lightweight, easy to maintain. There's some real benefits to the bridge, structural performance of the bridge with alternative B. And the third one was to try to recreate the appearance of the existing concrete rail that's there, using another concrete rail, something that we'd call a fellow guard. Well, in going through the structural analysis with ODOT, the reason why we had a couple of technical challenges was coming to terms with the design standard that this bridge would be designed to maintain. This rail is a little heavier than the steel rail. It's on the truss span. It actually produces a pretty significant load effect. So we found that it wasn't possible using a standard concrete rail to get the structural capacity of the bridge high enough to meet the modern standard that we need to achieve for safety. So we started looking at the steel rail in a little more detail. In our open house, we received pretty even votes between the concrete rail and the two-tube steel rail. And the reason why was people acknowledged that there was potentially some benefit with this rail. It is easier to maintain. It's just galvanized steel. That actually fades in time, so it turns to a gray that's very similar to the concrete color. And it's lighter. So if it's lighter, it preserves more capacity for load carrying capacity for vehicles. So we started looking at what we could do here, because structurally we couldn't get this one to work. And I can go into more detail about the approval process we'd have to go through for the concrete rail to get approval to make it work. Yes, sir.
Question, why wouldn't you do the opposite, just limit them, put a weight limit on the bridge and keep it, I mean, the big hoo-ha about the bridge is to keep it the way it was originally designed and looked, but the obvious seems to me is, if you want to look that way, leave it alone, and with that design, limit the weight. I mean, you don't, when you talk about weight, strength and all of that, the heavy weight that goes over that bridge has no business even being on it. Not to mention it limits the life span of the bridge, which you just said. Why wouldn't we want to lengthen the lifespan of the bridge on top of keeping it original?
Well, I'll explain our thinking. So with this rail, we can just achieve a factor of safety of 1.0. That means that for vehicles, truck traffic that's on the highway, the design code that we use is calibrated to capture the load effects of typical trucks that are on the highway. With this rail, we can achieve a 1.0, which means we have an adequate factor of safety for the vehicles that are out there traveling the highway. Anything less than a 1.0, and you don't have an adequate factor of safety according to the design code. This one, we don't reach a 1.0. It's a bit lower than 1.0. So from an engineering perspective, the concern is, we're putting citizens at risk because we're not maintaining enough live load carrying capacity to achieve that 1.0 capacity. And there's nothing out there controlling those trucks. Even if you put signs up, there's nobody controlling those trucks. So from an engineering perspective, we really like to see that 1.0 because it really is safeguarding the traveling public. It also, the load effects that truss sees, the stresses in that truss, it's the cumulative load of the dead load weight of that bridge plus the live load traffic going over it. So if we put additional dead load on it and we still see live load traffic that's unchanged, we are upping the stresses in the bridge. And eventually that could lead to cracks developing in the truss and shortening the performance life. So when you looked at the original ODOT reports that were done in the mid-90s, it suggested that this rail would just work. When we went back and reran the calcs according to the modern design code, it doesn't work. So there's been some improvements to more accurately capture the load effects inside the truss, and that's what we're using today, and that led us to this design. But so we started working on this concept to see what we could do with it, and we developed a concept. We've discussed it with the county. We've presented it to the State Historic Preservation Office. We have a strategy for maybe making this steel rail a little more attractive, and that's what I wanted to present to you tonight. We've already, like I said, discussed this with the State Historic Preservation Office. They support it. They're willing to let the project proceed if there's general consensus that this is a pretty good treatment to have. And here's the strategy. The truss band is really the part that we need to keep the load down. So what we'd like to do is use the two-tube steel rail on the truss band and then add a concrete end piece that recreates the visual appearance of the existing fellow guard. So you can see The only difference between this end piece that ties into the steel rail versus the fellow guard that's there right now is it's a little taller. But it has the same scuppers, the same reflector pockets. This has been done on the Newport Bridge, the Aquina Bay Bridge, on a couple of other bridges as well. And to really maintain the feel of the bridge, what we want to do is maintain, we want to match the ends of the fellow guard. So where that existing traffic rail ends right now, in all four corners, we want to match those. So in this corner where that fellow guard has a nice sweeping radius and then curves down to the deck, we want to recreate that, but we need to change the geometry of that top line just a little bit. So we don't have any hazards, so vehicles can't hang up on any snag points, that sort of thing. So this is the concept that we'd like to move forward with. Like I said, the State Historic Preservation Office has scrutinized this. They've accepted it, and they've said that they would consider this a no negative impact on the bridge. Keeps the weight, the dead load weight light, so we can make sure that we maintain adequate traffic safety. And it really does provide a crash-rated protection for the truss. One thing that our fellow guard that's out there today doesn't do is provide adequate impact protection on that truss. So a truck could actually jump that fellow guard and impact one of the primary metal steel members and cause the truss to fail. So this is a crash-tested rail that provides reasonable assurance that that's not going to happen. So, feedback on this question. Yes, sir, Frank?
Go ahead.
I understand the engineering and all that. What bothers me is the slope coming down. To me, that's an invitation for skateboards.
We would
Unless we put razor blades.
Well, what we do, we provide skateboard lugs. So they're stainless steel lugs that are cast into the concrete, so they can't just be popped off. And you space those about every 4 feet, so a skateboarder can't ride down that surface.
Okay.
Yeah, that's part of the design.
Will we be able to sit on that during the Sheridan Days parade?
Yes, this is only about 8 inches taller than the rail that's there right now. So,
People ask that.
yeah, that was a public question, yeah. So it's only about 8 inches taller, but it is crash test. So it will deflect vehicles and prevent them from hitting the truss.